Hello, everyone.
Hello.
Uh,
Hello.
I'm waiting, looking at names. Not many are here yet. They're adding.
Professor, did you take roll yet?
Can you talk a little bit louder? I have some problems with this sound. Just 1 second, please. I will close the door. Maybe it will have better result. Just 1 sec. So, yes, guys.
Did you take roll yet?
What?
Did you take roll or?
No, not yet. Not
Oh,
yet.
okay.
I will. I will. You know what? We have a technical problem. I'm talking not just us, entire college. So, because we are so actively, I'm talking about all professors recorded our lectures in the cloud. So we overseeded its capacity. Now it should be done in a different way. We need to actually create YouTube accounts and to have our recordings, because actually a recording of my lecture was in settings like automated actually process, but now we need to download this in our YouTube actually accounts, and I will try to resolve this problem to make everything available again. Another thing what I want to talk about is about tomorrow and about coming break, which is also very important. So as you know, we discussed that at the beginning of semester. Tomorrow is 27th, and according to the uh, plans which we had, I'm talking about college-wise, we had at the beginning of semester, it is a flex day. And they have several different options. But one of option is just to treat this as a regular flex day, as we usually do without these extra negative circumstances. So this why we need to talk about that. We received emails from the management saying that we could be really extremely flexible and decide what to do with that flex day. I think that for all these last 2 weeks, it was too much of negative stuff for all of us and our families. This why I decided to treat this flex day as a regular flex day, and I will release you from any meetings. So we will be just doing this, like if you need to use it for personal use or you like to do that, uh, reviewing some material, but I will not have lecture with you tomorrow.
Okay.
This is first thing. Second, we are going to use actually the next week also to review, to relax, because we will have a spring break. But if you check your Wiley Plus, you can see that there is a homework assignment already open for the 5.3 section. At the same time, if you checked Wiley Plus site, you could see the online quiz, also number 10. Did you check these sites?
Yes.
Yeah.
So this what you will be responsible for, this actually quiz. You need to finish that before it has a due date and time. At the same time, your homework has very, very long time interval. It will be due after the break. Is it clear for everyone?
Yes.
So If you have some questions about this information, which I just released, feel free to talk to me. Otherwise, I will talk right now at the beginning about the quiz, because I managed to check everyone's quiz yesterday. And at the same time, I sent personal emails with information about their grades to everyone. Do we have anyone who did not receive my email? Otherwise, does it mean that everyone received my email? Yes?
Yeah.
Excellent. Okay, let me grab actually your results. At the same time, I need to proudly say that many of you did quite good job, and I'm very happy. The highest grade in the class for this quiz is 100%. And quite many people got attractive grades. Unfortunately, at the same time, some people did not get attractive grades, but this is why I'm going to go over all details, so you will learn how to do that properly and not to repeat these mistakes when we have tests for these chapters. What I'm going to do, I will try to do two things at once. I will call your names because I have here names of people that it will be much longer because it is in very small size. I'm talking about printed on the screen when I see your names. What I'm going to do, I will show you right now, as I practically do that all the time, solutions for this quiz. And at the same time, I will be checking attendance. How can I handle this? I will see, but I will try to do that. Is it okay with you? Guys?
Yeah.
Yeah.
So
Yeah,
this
it's okay.
what you see at the top. This is information about this allocation of points. Okay, Andrew, I heard your voice.
Yeah.
You are here. So Tima,
Hello.
hi. Lorraine,
Here.
Lynn,
Here.
okay. Juanita,
Here.
Christian, Yaran, Yaran, Gabriel,
Here.
Divina, Divina, Kobe,
Here.
Chantal, Chantal,
Here.
Ricardo, Hochital,
Here.
Gongsi,
Here.
Kyle, Kyle,
Here.
Matthew,
Here.
Julian, Julian, Nathan, Nathan, Alejandro.
Here.
Okay. Let's start. This is your first problem, and you had to solve this exponential equation. I showed here all details because, again, we had 3 to the 2x. I really recommend you maybe to grab a piece of paper and write this so you will have it before we solve these problems. I'm talking about college-wise, about having recorded videos available. So this why I first think what I did, I tried to bring powers to the same base. This why I converted 27 into 3 cubed. So instead of 27 to the x, I have 3 cubed in parentheses to the x power. And after that, I simplified and I finally got 3 to the 5x equal to 43. Unfortunately, some students, when they use logs to log both sides, they logged one side, but they forgot to log the other side. And this is why they got a mistake right there. If you are logging one side, you have to log the other side right away. And you can see you have here two versions for x. One is showing the exact answer, like using decimal log. It is log of 43 divided by 5 logs of 3, or approximated, and I ask you to approximate to the nearest hundredth. So we need to have two digitals after decimal point. Unfortunately, some students violated this request. This time, I did not reduce anyone's grade for that, but honestly, the next time probably I will, because if I request rounding to the nearest 100, please do that. Pay attention to all requirements. And I don't need to review in this problem because originally it was an exponential equation. Do you have any question about this problem? Guys, English has yes and no.
No, no
No.
questions.
No. Okay, and honestly, practically, I would say 99% succeeded with that problem. Unfortunately, we had more problems in problem number 2. Wrong simplification. Okay, let's see what we have in second equation. Second equation is a logarithmic equation. And ladies and gentlemen, you cannot ignore parentheses around natural log because you cannot multiply exponents here. This is a major mistake which erases all future steps if you did that at the beginning, because you need to follow the order of operations. Again, you cannot raise e to the second power because it is not second power of that e to the 3x minus 2. It is a second power for the log. So it is basically natural log squared of e to the 3x minus 2. Please fix that on your paper because you definitely should have your solution in front of you. So the expression replacing original expression which you had in parentheses is 3x minus 2. And you can see outside I have square. So square of 3x minus 2 is 16. I'm taking square root from both sides, and this is what I get, 3x minus 2 equals positive and negative 4. I'm breaking this into two separate cases, A and B. I like to show this 1 second. I'm breaking this into two cases and separately solve each. I really apologize. I'm trying to find the better way. So 3x minus 2 equal to 4 and 3x minus 2 equal to negative 4. Solving each for 2, you are getting x equal to 2 as first value, x equal to negative 2/3 as the second value. But everyone who did not check got subtraction of 2 points because this time checking is mandatory. Checking is mandatory, and you can see detailed check because some people even trying to check missed important steps, and I was forced to reduce grades for that as well. But if you did not check at all, I subtracted 2 points. Total number of points for this particular problem was 5. Not checking, minus 2 points. Can I remove?
Yes. Yeah.
Can I start talking about the last problem?
Yes,
Yes.
please.
Quite many people succeeded with that problem number 3, which made me quite happy. But at the same time, ladies and gentlemen, we have two different exponential models. One model is so-called discrete model. Another model is a continuous model. Definitely, in this problem, you need to use a discrete model because unfortunately, some people use a continuous model. No, if it says that this account earns 6% annual interest, it means interest is calculated once a year, not continuously, all 365 or 366 days continuously. No way. It is being calculated only once a year, annually. This is a discrete model. Another comment, we do not have here variables. So basically, we need to define variables because your model should look as an equation. It cannot be just 850 times 1.06, blah, blah, blah. It should be something equals to 850 times some other components. Please be careful with everything what you do with word problems. You can see how I start the problem. I first defined variables and I'm saying let be balance in dollars. T is time in years. I really apologize. I think it looks a little bit blurry. Is it?
No, it's fine.
Okay.
It's okay.
So I converted R into decimal, and after that I continue showing that B at T, which is the balance after T years, it is a function of T, and I'm showing that initial value was 850. So right here you have that model. Your model is right, final model is right here. B at T equals 850 times 1.06 to the T power, which lets me actually divide both sides by 850. And I have shorter version. Instead of 5,200 over 850, I have 520 over 85, which I also, you can see right here in the second column, reduced to 104 over 17 because I divided again both 520 and 85 by 5. And this is much easier to have smaller numbers. And after that, I logged both sides, applied formulas for logs. So instead of log of 1.06 to the T power, I have on the right side T times log of 1.06, divided both sides by the coefficient of T, which is decimal log of 1.06, got exact value of T, approximated, and I really do not understand how some people having 31.08, again, having, let's say, 31.08, how they rounded this to 32 years. If you have 31.08, and if you are rounding, you are getting 31.1 of the year, not 32 years. It is an arithmetic mistake. And at the end, you can see the verbal answer that after about 31 years, the balance in this account will be $5,200. were you able to write down some notes on your papers?
Yeah.
Can I remove this paper?
Mm-hmm.
That's fine.
Okay. I'm ready to answer all additional questions if you have about any of these problems. They were 3 quite short, easy problems. If some of you feel that you did not have enough time in these 30 minutes, it means that you are struggling with some of these type of problems. Please try to review all solved examples. We solved quite many examples of that kind in our virtual class and in our regular class. So, and again, feel free to ask for help because all the time, I'm available to you during office hours, definitely also online office hours. So feel absolutely free to ask for help. With your permission, can I now start solving more problems from 5.3?
Yes.
Yeah.
Okay. So let me see what we did, where we stopped, and I will, you can help me to restore what I have here, but I think this was the last problem which we solved yesterday.
That's right.
Okay, and this was on page 209 in your textbook. Can you precisely look at these 2 exercises like S9, SS10, and tell me if you need any of these right now, and I will go from there. You need to rewrite the expression as a single logarithm. Would you like to see maybe S10?
Yes, please.
Yes, okay. S10. Let me copy what I have. 1/3 decimal log of 8 minus 1/2 decimal log of 25. This is that problem. And I need to simplify and rewrite the expression as a single logarithm. Let's do that. First, I pay attention to that coefficients which I have in front of that logs. Is it 1/3 and 1/2?
Yes.
We have formula for the log which takes care of that situations actually, because we had, let's say, log of the power with exponent. And what did we do? We grabbed that exponent and moved this all the way down to the front of the log. But this is the formula. It has the equal sign. It works in both directions. Before that, we practically all the time were doing what? We were applying the formula from the left to right. But sometimes we need to apply formula in opposite direction from right to left. And this is that case. What can I do with this 1/3? I can move it up, like writing down log of the 8 to the 1/3. I can do the same thing with that 1/2. 25 to the 1/2. So far, so good?
Yeah.
Yes.
Now, 8. Is it the cube of any number?
2.
So write it down that it is 2 cubed. 25. Is it a square of any number?
5.
And why? Because I had 8 to the 1/3. This is why I was interested in the third power. I had 25 to the 1/2. This is why I looked at 25 as a square. Inside of the log symbol, is it power to the power?
Yes.
Can we
Yeah.
multiply exponents?
Yes.
If you multiply 3 by 1/3, is it just 1?
Yeah.
If
Yeah.
you multiply 2 by 1/2, is it just 1 again? Do you get that?
Yeah.
Do you have any formula for the log when you have a difference of 2 logs? And again, try to look at this formula from the right side to the left. Is it the log of the quotient?
Yeah.
Yes.
That's it. Apply that formula. And you have log of 2/5. Now we already have single log. The only thing is, I don't know if it is stored, let's say, in your Wiley Plus log of 2/5 because it is legal, or we can simply divide 2 by 5 and we can get the answer in decimal form. If you divide 2 by 5, is it 0.4?
Yes.
So basically, both answers are legal. We have one single log, decimal definitely, of 2/5, or it can be decimal log of 0.4. We are done. Questions?
No.
I am moving to page 210. And here we have exercises again on the top of this page. You have 2 problems. Like what? In exercises 1 through 2, find the domain and the range of the function. Is it okay if we grab function in problem number 2?
Yes.
Okay. Page number 210. Problem number 2. Y equals natural log x plus 1. I would like to remind you right here on the side how logarithmic functions graph can look. First of all, I would show you right now a connection between, let's say, exponential function and logarithmic. Let's say that we have y equal to 2 to the x function, and we have y equals log with base 2 of x. You can see here I'm using same basis for both functions. It is 2 to the x and log with base 2 of x. We already talked a lot about exponential function. This is fitting the formula of a times b to the x. I'm talking about 2 to the x. Here, a is 1, b is 2. So this function has very nice looking graph. The name of the graph is exponenta, and it has horizontal asymptote. It will be vertically running through the point 0, 1, because 2 to the 0 is 1. I'm quite roughly, without point, sketching the graph. Does it look familiar?
Yeah.
Okay. And you can see here that when x is approaching here, x is approaching negative infinity, y is approaching 0. So here, x-axis is a horizontal asymptote. These two functions are inverse to each other. And this y, you covered these functions in Algebra 120 course, definitely. And basically, to do, excuse me, to graph the second function, it will be enough for me to use a so-called bisect of the first quadrant. Bisect of the first quadrant is a line with equation y is equal to x. I just showed this dashed line which cuts the angles in the first quadrant and the third quadrant. It cuts these angles into two congruent angles, 45 degrees. This is a bisect of the, we call it bisect of the first quadrant, but actually it is a bisect of the third quadrant as well. And just you can symmetrically reflect that graph, which was y equal to 2x over that bisect line. So, and voila, you are getting another graph. These two graphs, and let me label actually, because we have here more than one graph. It is 2 to the x. This one is y equals to the log with base 2 of x. These are two graphs. And just looking at these two graphs, we can say many things. Can we say that log function has vertical asymptote?
Yeah.
Can you see that when x value is approaching 0 from the right, the tail goes down of the graph, tail of the graph goes to negative infinity?
Yes.
I'm ready to write down right now domain and range for both functions. D1 is domain for exponential function, and it is definitely set R. The range for the same function, you can see entire graph is above x-axis. So which means it will be open interval, no brackets. It will be from 0 to positive infinity. D1 is set R. R1 is open interval, or just you can simply say interval from 0 to positive infinity. What about domain and range for logarithmic function? I will be using D second and R second, D2 and R2. Let's start with domain. Can you see that entire graph of this function is on the right side from y-axis?
Yes.
The tail goes down infinitely, but it will never touch y-axis or cross it. So which means if we are talking about x values, can we say that x can infinitely go toward positive infinity, reaching positive infinity end? Can you see that this top tail for log can be continued forever? I have no restrictions, which means it can reach positive infinity. At the same time, when it moves closer to y-axis, It will never touch it. It will never reach it. It means x cannot be equal to 0, which means domain is interval from 0 to positive infinity. Now, what can we say about the range? With each move to the right, that top tail of y equal to log with base 2 of x, it comes higher, 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 higher. If we have x moving to positive infinity, which means that tail can infinitely go up. Is it clear to you?
Yeah.
At the same time, if we are moving closer to 0, and we can move closer to 0, I'm talking about x value, only from the right side, the tail, the bottom tail, infinitely goes down, reaching negative infinity. So basically, y value fluctuates between negative infinity and positive infinity. Is it set R?
Yes.
Can you compare this information for first function and the second? Do you see any special thing?
Their inverse.
Is it first domain becomes, for the second, it becomes the range?
Yes.
And the first range is acting like a domain for the second function? Yes? So which means, if we describe that in different form, what can we say? If domain is from 0 to positive infinity, it means that x should be greater than 0 all the time. I'm talking about the log, right? At the same time, for the first function, x is running between positive infinity and negative infinity, which I also can write, and I wrote it right here, right here. What can we say about y? Y for the first function is positive all the time. Oops. But for the second function, y can run between negative infinity and positive infinity. This is very important. I basically lectured right now about connection between exponential function and logarithmic function. This is your old material from intermediate algebra course. I just tried to remind you that. This why now I can quite easily use this all information to talk about function in problem number 2, which is y equal to natural log of x plus 1. And they are asking us to find here domain and the range of that function. I will first start talking about domain. What should I do? In this function, we have natural log. Is it base greater than 1? Why I am asking you about that? Because right now on this graph here, I will show you different situation. Let's say y equals to 1/2 to the x. In this case, I will show you dashed form of that graph. This is, I hope you can see right here. It is a dashed, it is right here, symmetric to the 2 to the x, only it is decreasing function. But again, the domain here is all real numbers. Range is also all non-negative, positive, actually positive values. What about the graph of logarithmic function if the base is less than 1? Because for the log, we can have base as any positive real number except 1. In this case, for this particular function, base was of this log was 2. If it is, let's say, log with base 1/2, it will be similar type of curve, only this time it will be decreasing. You can see that dashed graph. Because log with base 2 of x and log with base 1/2 of x, they will be symmetric with respect to x-axis. But the dashed log's graph, the graph which is dashed, is decreasing. But natural log has base e, so e is about 2.72, so which means it will be that type of graph which we had in the solid curve for the log. But what should I write here? X plus 1 should be greater than 0. This is what I'm stating here as an inequality. And you need to solve it for x. Is it x greater than -1?
Yes.
In other words, if we show this on the number line, is it -1? And on -1, we need to place open circle and go to the right side from -1.
Mhm.
I use shading. You can use arrows if you like, going from -1 to the right. I'm ready to write everything for the domain. Is it an open interval?
Yeah.
So place round, don't use bracket, please. So -1, comma, infinity. And I answered the question about this. I again do not know how it is stored in Wiley class because they can write, let's say, all real numbers greater than -1 as a sentence, or they can write just x is greater than -1, means this is information about domain. Definitely the most modern and most mathematically attractive form is the last one. Domain is open interval, or we just can say interval from -1 to infinity. They all carry the same math meaning, even the sentence. Now we can talk about the range. If you compare, let's say, function natural log of x plus 1 or natural log of x simple, these two functions have parallel graphs. The only difference between y equal to natural log of x and y equal to natural log of x plus 1 is a horizontal or so-called phase shift, which you talked about a lot in trigonometry course. Because you have x plus 1, and we talk about horizontal shift from y equal to natural log to get this desired graph, you need to shift it into direction opposite to this sign, which is plus. Opposite direction is for minuses, which means to the left. So if you need to build the graph of y equal to natural log of x plus 1, having in your possession graph of y equal to natural log of x, you need to grab this natural log of x graph and move it 1 unit to the left. But it is not going up or down because we do not have here so-called vertical shift, which means that particular function has range as all all other logarithmic functions for which, let's say, base is any number greater than 1. Actually, if base is less than 1, they also have same range. So which means you can write range is equal to set R if you like. You can write that range is equal interval from -infinity to +infinity, or you can write this as a sentence that range is all real numbers. I purposely actually lectured so much about these functions because it is like basic type of information which you can use solving all these problems. Let's say 3, 4, 5, 6, number 7, number 8, choosing proper functions, 9 or 10. Definitely, I will lecture more after the break because I, again, did it purposely, trying to show you actually many important details about these functions. I hope that everything what I quickly try to remind you about exponential functions, logarithmic, connections in between, and vertical and horizontal sign asymptotes will help you to restore this information, because so far I did not use any new material. You learned all this information in your previous classes. Do you think that reminder was helpful for you?
Yes.
Okay, now I would like just to say a few words about, again, vertical asymptotes, because we already talked about horizontal asymptotes and how we can write them down. Let me again remind you right now, I'm going to write this again about horizontal asymptotes. Horizontal asymptotes. If we have function f at x and limit of f at x when x is approaching positive or negative infinities equal to this certain number, let's say a, limit when x is approaching positive or negative infinities for f at x equal to a, then you have a horizontal asymptote which has the equation y is equal to that a. This is about horizontal asymptote. In other words, if x is approaching positive or negative infinity and at the same time y is approaching that a, then y equals a is your horizontal asymptote. You can write this without limits in that bottom line, on the bottom line below a limit form. You can see that. What about vertical asymptotes? Vertical asymptotes. We can describe this situation also using different forms. Limit form. This time, your x should be approaching certain number, let's say number b. Doesn't matter from the right side or from the left side or from both sides, which is also possible. If in this case, your limit will be equal to positive or negative infinities, you can see in the case of horizontal asymptote, this limit was equal to this certain constant number. But in this case, this limit is equal to positive or negative infinity. Then vertical line with equation x equal to that b is your vertical asymptote, because any vertical line has equation x equal to the number, fixed number. If you like to write this without limits, yes, you can do that as well. If your x is approaching b, again, doesn't matter from right, from left, or from both directions, and at this time, it forces your f at x approach one of infinities or both, then x equal that number b is your vertical asymptote. So you can see that on this graph with logs, because x is approaching 0 from the right, if b base of the log is greater than 1, then tail goes down, reaching negative infinity. At the same time, if actually you have base for the log less than 1, then you have that dashed graph. X is approaching from the right to 0. At the same time, that dashed tail goes up and up and up, reaching positive infinity. So the vertical line x equal to 0 is a vertical asymptote for these logs. I'm stopping on this actually material because I don't have time anymore. Be a little bit patient. As soon as our recording through now YouTube is available, I will try to send you all link as I did before. But again, the entire college right now struggles with that type of things a little bit, but the problem is solvable because we used all capacity of recording in the cloud. Many of us are using this option. This is why there is no space for that type of recording as we had before. With your permission, can I finish my lecture?
Yes.
Yes.
Okay, ladies and gentlemen, I will see you after the break. I wish everyone only good things. Stay well, try not to catch any viruses, and I wish the best things and to you and to your families. Okay, and I hope that our lectures were helpful for you to comprehend the material. Can I say everyone extremely warm goodbye?
Yeah.
Bye.
Okay,
Bye.
Bye,
have a
Professor.
nice, beautiful day and have nice, beautiful break. And don't forget to review some math during that break as well. The best wishes. Goodbye.
Bye-bye.
Bye.
Bye.
Bye.